Let's look at practice problem 5-1. And this is a very simple truss analysis, but we'll use it to demonstrate all the steps. So the first thing we do is we verify that this is actually a truss, and that mainly means to look at, are the loads applied to the pins? In this case, there's only one load. It's 10 kips, and it's applied to the pin or the joint at point number B. All good. Second thing, let's label all the parts of the truss. A, B, and C, they're already labeled for us in the problem statement. That's not always the case. So in this case, we're good with that as well. Next, truss geometry. I see that this truss has a bottom base of 10 feet and two 45-degree angles. The biggest thing I need to know then is that with two 45-degree angles, that 10 kip load is applied directly in the middle, or 5 feet from either end. Okay, if you needed to, you could also figure out the leg of each, or the length of each one of those legs. Okay, and then it's a simple 45, 45, 90 triangle, and that means those two legs are 10 times the cosine of 45, or 10 times the sine of 45. They're both the same, and they're 7.07 feet. Don't really need to know that for this problem. So everything we've got here is good to go for a truss analysis. So the next step is to find the reaction forces. And the way to do that, draw the free body diagram of the entire truss as if it were one complete solid member. And we have three forces. We have a single roller on the right side at point C. We have a pin at point A, and a pin always gives us two forces. And I'll call this CY, AY, and AX. In addition, we have a 10 kip load, and that's right at the center. So this distance is 10 feet, and this distance is 5 feet. Okay, we can now look at the sum of the x forces equals 0, and that equals AX. There are no other horizontal forces, so very simple. AX equals 0. I can pretty much ignore that, but you should always check that just in case. Now I'm going to do something slightly different. I'm going to take the sum of the moments about point A. So when I do this, if I extend the 10 kip force down its line of force, I have 10 kips. That is exactly 5 feet away from point number A. So 10 kips times 5 feet, and that rotation is clockwise. Then if I look at CY, it's 10 feet away. And those two equal 0. 10 times 5 is 50. Equals CY times 10, or CY 50 divided by 10, or CY equals 5 kips. Okay, Now if I take the sum of all the Fy forces, I have a negative 10 plus Ay plus Cy, which I know is 5, and those all equal 0. Or if I solve that, substitute the 5 in for Cy, move the 10 over the other side, change its sign, I'll end up with Ay equals 5 kip. So now I have Cy is 5 kip, Ay is 5 kip, and Ax equals 0. Okay, I am now ready to solve for the forces in each member. There are 3 members we need to solve for, and I will perform the method of joints at each corner of this truss, or at least 2 of the corners. I'll start at point A, and at point A I have a force of 5 kips pointing upward. I have a force pointing to the right. Remember, for a truss, the forces are always in the same direction as the member. So this is force AC. It's the force in member that goes between point A and point C. We also have a force that goes between A and B. And I know this is 45 degrees. Okay. I immediately can break this up into x and y components. This is already in the x direction. Force AB has 2 components, FAB times the sine of 45, and FAB times the cosine of 45. And now FAB drops out of that equation. Everything now lines up in the x and y directions. So let's start with the y forces. The sum of the forces in the y direction, or the vertical forces, equals 5 kips going upward, it's positive, plus FAB times the sine of 45. Those two have to add up to 0. Everything going up has to equal everything going down. Well, I've drawn these both going up, which means one of them is incorrect, and that would be this guy, because that's the unknown. I know this one's going up. I can now solve for FAB. Equals negative 5. I take the 5, put it on the other side, change its sign, divided by the sine of 45. And I end up with FAB is negative 7.07 kips. And the negative means it's really pointing into the pin. That means it's compression. This is one of the reasons, if I don't know or don't see the direction immediately, I draw them as positive. that means going out of the pin. And if I get a negative number, it means it's under compression. I know one of my 3 unknowns already. The sum of the X forces at pin A is now FAC plus FAB cos 45 also equals 0. FAC is the unknown in this case. So FAC is simply negative FAB. Well, FAB is negative 0.707 or 7.07 times cosine of 45. 7.07 times the cosine of 45, and the 2 double negatives cancel, and it will be 5.0 kips. And it's in tension because it is positive coming out of pin number A. I have one more unknown, and that's at pin C, which also has a force of 5 kips, and there's a force coming out of here of 5 kips. That's FAC, which I know now. And then I'm going to assume that this unknown force, FBC, is in compression. Now I'm going to do this one in a slightly different manner. I've got this force which I know, and this force which I know, and this force which I don't know. But I do know that this vector plus this vector plus this vector have to add up to 0. So if I put them all nose to tail, vector addition, they will end up in the same place, which is a result of 0. So when I have 3 vectors like this that all go through the same point, I can just rearrange them slightly and have 5 kips, 5 kips, and FBC. This is 90 degrees. 5 and 5. I can now use Pythagorean's theorem on this. Okay. So FBC equals the square root of 5 squared plus 5 squared equals the square root of 25 plus 25 is 50, and that equals 7.07 kip. I could also, as another way to do this, I could say FBC equals 5 kips divided by the cosine of 45 degrees, which also equals 7.07 kips. Whichever way you want to do this, but there are 3 forces, and again, I've drawn that in compression so everybody is in the right direction, and FBC is 7.07 compression. And that gives us the 3 forces in this truss. Let's just summarize briefly. This is 7.07 compression. This is 7.07 compression. And this is 5.0 in tension. And that's due to the 10 kip load there, and a 5 kip load there, and a 5 kip load there. And this is the final answer.